This is my glider project by Nicholas Schweiker. So for the project requirements, the goal was the glider must go more than 20 feet standing on level ground. And then for the requirements, the glider must be hand thrown, must fit in a square box that is 16 by 16 inches from a top view, must stay intact during flight. There's no active control allowed. It must be a glider shape, meaning it has wings and is only propelled by the initial throw. And it must be made primarily by balsa wood and assembled in the AE makerspaces, and supplementing materials is allowed as long as it still meets the above criteria. So for the design process, to start out with materials, I use only balsa wood and Play-Doh because the glider must be mostly made of balsa wood, and Play-Doh is a variable weight that can be easily added to different points on the glider. Could have used some metal for the wings that would have shifted the center of gravity back, but that would have been hard to install. And I could have used alternate weights like bolts or nuts glued to the front, but then that weight cannot be easily adjustable and tested. For wing placement, I used the diagram to the right where I found the width of the wings and then CG using that equation so there'd be no net torque. And I found the most optimal spot, so I did not consider any alternatives. For the wing shape, I went with a tapered wing design. This reduces drag because the aspect ratio increases towards the wingtips, allowing it to fly further. And then lift across the wing is more evenly distributed, decreasing the chance of the tip stalling and increasing the stability. I could have used a swept wing, but that has reduced lift and stability at lower speeds, and that is more for commercial airplanes, so I decided not to go with that. So for the design process, I decided not to use a dihedral because it would have been hard to manufacture and install on the glider, and I was worried it would make it more fragile and then would break during the test flights. The dihedrals also increase drag, and for my first and second design tests, I did not have any stability issues, so I decided it was not needed. For the tail configuration, I went with a pretty standard tail. The horizontal width was 5 inches, and the vertical height the vertical fin was 2 inches. This most might be on the high side, but I wanted additional stability because of the lack of the dihedral. For adhesives, I use super glue because it's strong and lightweight. I could have used epoxy, but that takes a long time to set in. And then I also could have used tape, but that would not have been strong enough. So to balance my glider for longitudinal stability, I place the center of gravity slightly ahead of the quarter chord point on the wing, which is a quarter of the distance from the leading edge. I found the right center of gravity position through experimentation of balancing my glider on my finger and adjusting the placement of the Play-Doh. I conducted many test flights with moving the position of the Play-Doh forward and backward and the amount of Play-Doh, therefore changing the center of mass to find the optimal position. I found that the optimal position was at the tip using roughly 3/4 of the Play-Doh on the front tip, leaving the center of gravity as that green dot on the picture. So here are my lift and drag estimates for the lift. I used the equation provided and I found that it was roughly 7 thousandths of a Newton. And for induced drag, I found it was roughly 8 thousandths of a Newton, where I calculated the aspect ratio myself and plugged that into the equation we were given. And then to find total drag, I just doubled the induced drag to be 16 thousandths of a Newton. So for design iterations, I made one previous model where the wings were made out of cardboard and the fuselage was made out of the rectangular balsa wood rod that we were given. After making this, I did some test flights. Here's the SolidWorks pictures to the right. I increased the back wing width and height for added stability and to fit the ideal ratio with the main wing. After making this model, I did main wing placement calculations because when I threw it, it curved up and went out of control. The model was generally small, so I increased the length of the next version to 10 inches and I increased the width of the main wing to 12 inches. So here's the final design I went with. You can see the SolidWorks pictures to the right and that it clearly fits within the 16-inch by 16-inch frame. The glider was designed to be somewhat smaller and compared to other people's gliders. This was done to allow more power in the throw and decrease drag. The glider wing width is only 12 inches. The back wing width is 5 inches. The back wing vertical height is 2 inches. And the overall length of the glider is 10 inches. So for the test flights, I never captured a video of the cardboard first version, but it went around 15 feet, but it was very inconsistent. It frequently would fly up and then do like loop-de-loops and then crash into the ground going maybe 5 feet. The previous model's key points were the pointed tip for reduced drag, the large tapered wing to have large amounts of lift, and Play-Doh placed in between the front of the wing and the tip to try to get an optimal center of gravity. The final model's key points are small size, easy manufacturability, tapered wing, and the ability to change the mass and center of gravity with the Play-Doh, which was ended up putting on the tip to have the ideal center of gravity right in front of the quarter cord. The final glider design performed decently well, going 42 feet, and in my testing went an average of 40 to 55 feet on average, which is way above the required 20 feet minimum. I believe my glider performed decently well, going 42 feet in the official test, but I did hope that it would go further, as in many of my unofficial tests, I reached 55 or even 60 feet, and I saw many groups in the official testing going 80, 100, 100 plus feet, so I wish I was on that caliber. The design, I believe, was thorough and well researched. I did lots of calculation, and paired with the strong construction using super glue and the laser jet, allowed it to reach 42 feet. If I were to make this glider again, I would make it a lot heavier to allow me to throw it a lot further. This would kind of make it be like a javelin almost. That's what many of the winning groups did by having smaller wings and just a lot of weight in the front. And so I would have made the front section out of 1/2 inch steel by either layering 1/8 or 1/4 inch steel from the machine shop in the scrap section, and I would have used the water jet. I would have changed the wings to be dihedral, so when I would throw the new heavier glider, it would be more stable, even during that a lot stronger throw. And here are many of the sources I used. Thank you.